Hi, good morning, good afternoon, good evening. Never quite sure when people are actually watching these things. My name is Justin. I'm going to be your speaker today. But before I get into it, a little bit about me and my company. So I'm the business development manager for a company called OLSPS. You can see the logo in the top right-hand screen there. We've been around since, we're a data specialist. We've been around since 1989, so we are very much veterans in this space. And we focus very much on data management, statistics, and I guess you could say predictive technology, or data science is a more general, broader sense of the word, I guess. In terms of track record, we've implemented a number of complex solutions in a variety of different industries: telecommunications, retail, banking, insurance, government even. And we are a lean team of statisticians, mathematicians, engineers, and generally all-round very analytical people. I'm more on the business side of things, obviously, though my appearance might suggest otherwise. So if you want to hear a little bit more about our business and some of the work that we've done and the other areas of expertise that we have, you can come and chat to me after the presentation at the booth or at the speakers lounge, or you can get in touch with us in some capacity after the event. So, all right, on to our topic of the day. So that is on the screen in front of you, the OLSPS deployment platform, enabling business users to harness the full power of advanced analytics. Now, when we talk about, say, machine learning or artificial intelligence, these terms are pretty ubiquitous right now, obviously. But this kind of technology, or at least the foundations of it, has been around since, I think, around the middle of last century. I think the first paper on neural networks that was published, this was back in 1943. And since then, interest in this field has pretty much waxed and waned over the years until about the last decade or maybe 15 years. If we're thinking about a sort of wider commercial exposure, maybe the last 6 or 7 years, things have really started to take off. So much so that those of us who even work in this field often find it hard to keep up with the pace of change. So really what I want to focus on today is this gap that sits between hype and reality, or hype and practical outcomes. Now, there are numerous platforms, products, and technologies being released all the time that all promise to revolutionize your business, and you're often left with this feeling that if you don't jump on the bandwagon now, you're going to be left behind in some way. Now, if you have a corporate-sized war chest, that's one thing. But if not, adopting artificial intelligence, machine learning, or any sort of other discipline within this field can be a very expensive and potentially very risky venture. So the purpose of this talk is to introduce a platform which we have developed that we feel helps to bridge the gap between hype and reality. So a little disclaimer here, because this is quite a broad-ranging topic, I'm mainly aiming towards businesses and organizations that are trying to get value out of their own data, as opposed to new sort of off-the-shelf products and services, well, off-the-shelf products, I guess, which have AI or machine learning incorporated into them. So the name of the platform is OLSPS, as I've mentioned. I won't go into the origins of the name, but mercifully I will assure you that it is not a 6-letter acronym. And OLSPS is really designed to do two things. So it simplifies the deployment and management of advanced analytical solutions and gives non-technical business users a degree of control and ownership over the predictive models that are hopefully going to help them get a hell of a lot more value out of the data that their department is sitting on. Secondly, OLSPS is there to serve as a cost-effective way for smaller, could be medium or larger organizations really, to be able to start effectively incorporating predictive technology into their business processes and way of doing things. Firstly, a harsh truth. I'm going to begin here by talking about this gap between hype and reality. So I don't need to extol the virtues of AI, machine learning, and predictive analytics, because it's already become woven into the fabric of many of the goods and products and services that we use. So if you think about your bank, your insurance, Facebook, Netflix, it's everywhere. And whether or not this is universally agreed upon to be a good thing, ultimately, those companies and organizations who've managed to successfully adopt this technology they've managed to get a pretty significant competitive edge in their respective markets. But what I have on here is an interesting estimate or statistic. Many of you have probably seen this before in some form or another. I say some form or another because I've seen it used to quote big data projects, AI projects, machine learning projects, fill in the blank, you name it. And I've seen various figures, whether it's 94%, 81%. It doesn't really matter. I think the point I'm trying to make here is that despite all the hype and all the buzz, right, the majority of the time, these projects don't work out. They either fail to reach production, or they do go into production and they fail to deliver any real business insights. So this goes back to what I said earlier about how if you're a big corporate and you have a large budget to play with, it's one thing. But if you don't, if you have less money to throw around, then you have to take into account the possibility that your investment isn't going to pay off at all, at least initially. So the question is, well, if in some sense I'm expecting this thing to fail, if the chance to failure is so high, then how do I go about getting some kind of predictive value out of my data? All right, how to knock it out of the park. I'm definitely being a little bit facetious with that headline at the top there. There are probably thousands of listicles out there, many of them written by non-technical people like me or journalists, which detail a 5, 6, or 7-step process, which is going to tell you how to make your data science or machine learning or artificial intelligence project a success. There's nothing wrong with that, but I think as the studies show, you can follow all these best practices, but in reality, there are many different moving people, parts, and processes that all have to dovetail really nicely for things to work out well. And it is very hard to get them all to do that. So if you are going to adopt predictive technology in some way, especially into an existing business with legacy infrastructure and processes and whatnot, there are some requirements you need to keep in mind. Firstly, you need staff with highly specialized skill set and ideally also having end-to-end implementation experience. Secondly, it often requires having complex systems and software in place, and whether it's systems or staff in this case, this may result in major changes to existing business processes, particularly if you're adopting a fancy analytical platform or if you're trying to recruit a whole data science team. And that impacts the third thing. And this is possibly the most significant challenge of all, and this is getting end user adoption, business buy-in, because that's the purpose here, right? The goal of all this is to get insights out of your data, and you want to give those insights to your business units, and you want them to turn those insights into value for the organization overall. So what am I saying with those points? Well, we're talking here about time, cost, and complexity, and the risk that goes with all of that. So if you maybe go to a typical platform provider, analytical platform provider in this case, let's say an IBM, a TIBCO, a SAS, or something like that, they have some wonderful tools available, but they are often very complicated. They're often continually evolving to keep pace with technological change and the rest of the market, and they usually have a price tag that also make your eyes water. Secondly, if you're wanting to recruit an in-house team, data science team, to use that platform potentially even, you're going to have to spend a lot of time and money getting the right people in. And once you have them in, you're going to have to spend a lot of time and money keeping them there, because senior experienced resources are both crucial and the market for them is highly competitive. We are a data science business, take it from us, we know. So to successfully adopt predictive technology, it requires an experienced multidisciplined implementation team, be like OLSPS, for instance, and to simplify complexity, minimize business impact, and maximize end user adoption requires a different kind of analytical deployment platform. Right, so this brings us to OLSolve, complex analytics simply delivered. In a nutshell, OLSolve is a deployment platform for integrating advanced analytical models into your business, right? Here I'm referring to things like predicting customer behavior, who will buy what product, who's likely to default on a loan, who's likely to leave your service. It could be predicting the likelihood of fraud, it could be forecasting revenues, or even forecasting weather patterns. Really, there is an almost inexhaustible range of applications here, but each one of those can take a lot of time, effort, and money to manage and successfully integrate into your business. And this is where the OLSPS platform comes in. So why does OLSPS exist in the first place? How did it come about? As I mentioned a little bit earlier, our company has had a lot of experience in complex solution implementations, and obviously each client has a different setup, different systems, and all the rest of it. So over the years, we've developed some sort of expertise. We become pretty well versed in systems like SAS and IBM, some open source systems as well. And I spoke a little bit earlier, especially in terms of the enterprise level platforms, how they can be very complex. I mean, they're often made up of a bundle of different products and technologies that are brought together to solve a number of different challenges across the analytical spectrum. Now, that means they're not really necessarily tailored to a specific client. And especially when you're talking about a smaller organization, in some cases, they simply don't need all the bells and whistles. And to be honest, all those bells and whistles can often just get in the way of executing a project efficiently. So this is the market OLSPS is designed to serve. We've trimmed off the fat, and what we're left with is a lean, mean, analytical deployment machine platform. So this brings us to OLSPS, complex analytics simply delivered. Right. In a nutshell, OLSPS is a deployment platform for integrating advanced analytical models into your business. So here I'm referring to things like predicting customer behavior, so who's going to respond to a certain marketing campaign, who will default on a loan, who might leave your service. It could be predicting likelihood of fraud for incoming insurance claims, it could be forecasting revenues, or it could even be forecasting weather patterns. Now, it's not quite inexhaustible, but there is a really large range of different applications here, but each one of them is going to take a lot of time, effort, and money to manage and successfully integrate into your business, and this is where the OLSPS platform comes in. So why does OLSPS exist in the first place? I mean, how did it come about? So as I mentioned at the beginning of the talk, the company has had a fair amount of experience in complex solution implementations. Each client typically has a different setup, they use different software, they have a different way of doing things. So our teams essentially become pretty well versed in a number of different platforms like SAS, IBM, a few open source as well. And I spoke earlier about how these platforms can be very complex. So they're typically made up of a bundle of different products and technologies, and they're set up to solve a pretty, a number of challenges across the broader analytical spectrum. So now, they're not necessarily tailored to a client's specific needs. So especially for a smaller organization, you simply don't need all the bells and whistles. And in fact, they can often just get in the way of executing a project efficiently. So this is the market that OLSPS is designed to serve. We've basically trimmed off all the fat, and what we're left with is a lean, mean, analytical deployment machine platform. It doesn't really rhyme. So what does OLSPS do? Well, OLSPS does three things really well. It dramatically simplifies the deployment, collaboration, and management of highly sophisticated analytics. Secondly, it makes those same high-end analytics accessible to non-technical users. Now, this is key, right? Because most platforms give ownership to the techies or data scientists and insights to the end users. This is slightly different because now the business end users have control over the models to some degree. So that's very important. And three, it integrates those analytics into an existing business flow seamlessly. And it does these three things at a much lower operating cost than other major platforms. So where does OLSPS fit in? Well, this is one of those diagrams that you're often told not to put into a presentation, but here it is in all its glory. Now, it essentially shows you a high-level view of an organization's data-driven decisions ecosystem. Now, that's a mouthful, I realize that, so I'm going to try and explain these components one by one so it'll make sense. Now, on the bottom, you have your data streams and data sources. This is really referring to data the business is sitting on. So it could be data sitting in a database or in Excel, or we're talking about real-time data streams, which effectively come from the integration layer above. So when I talk about the integration layer, I'm referring to the different source systems which interact with each other. This could be accounting systems, CRM systems, enterprise resource planning, websites, This is really where the data is recorded and integrated. And above that, we have a centralized reporting layer. This is a BI layer. Think Cognos, Tableau, ClickView. On the left-hand side, we've got domain-specific decisioning. Now, this is really the different departments. So accounting will be interested in some data. Your credit department will be interested in other bits of data. Your marketing department will want to predict other things. And then on the right-hand side, we've got the central decisioning. Now, this is really the executive or the C-suite level who want to have a higher level or view of what's going on in the different departments or different areas of the business. So OLSPS sits between that integration layer, remember that's different source systems, accounting, CRM and whatnot, and the BI reporting layer, which effectively drives many different business decisions. Now, OLSPS provides insights to the BI layer, automated decisioning in bulk, and also real-time automated decisioning, right? And this is all based on predictive intelligence and all seamlessly integrated into existing line of business systems. Now, a lot of companies tend to fall over here because central decision makers don't have easy access to the data or insights that the various departments are working with. But in this case, OLSPS is designed with non-technical end users in mind, and it's positioned in such a way the intent of trying to democratize the information flow within the organization, right? That's a bit wordy, but essentially we want the central decision makers to have much easier access to the same information that the various departments are working with so that everyone is more or less on the same page. Right, so there are three primary workflows with OLSPS, right? The first is the data scientist flow. Okay, this is typically where a team like OLSPS's in-depth knowledge and decades of experience would come to the fore to develop or customize a high-end analytical solution. Right, this is often a long and highly technical multidisciplinary process. The second flow is the line of business, right? The solution developed by the data scientists is then deployed to OLSPS and seamlessly integrated into the existing business processes with minimum impact. So this happens through two industry standard integration points. The first is databases, which facilitates the bulk decisioning and the BI insights. And the second are the REST APIs. So this facilitates the real-time decisioning, and this is for data that goes straight to your CRM system or your accounting system. So it's request and response driven. So the REST APIs allow OLSPS to receive that data automatically. And lastly, we have the business user. So end users are able to modify, schedule, deploy, and manage the high-end analytical solution via a simple and intuitive browser-based front end. So what does OLSPS look like? We've covered why OLSPS was developed, what it does well, how it fits into a typical business setup. So the question now is, what will the end user actually be working with? Now, before we get into that, I want to give you a sense of the complexity of the analytics that can be deployed to OLSPS. Now, this is what things look like under the hood, so to speak. So pictured here is part 1 of 3 of a recent version of our predictive behavioral management solution that is implemented at an investment bank in Australia. It consists of tens of thousands of operations and can process 30 million data points in a few seconds. I know those are just numbers. Believe me, there are not that many people out there who are able to make sense at all out of a model like this. I certainly have no idea whatsoever what's going on here. So when we talk about complex analytics simply delivered, this is the kind of complexity that OLSPS helps to simplify from an end user standpoint, or shield them from. Might even be a better way of putting things. Okay, so we have a little mini case study here, and for this case study, let's just say this is for a central claims authority or bureau for the non-life or short-term insurance sector. So in this case here, we are looking at a revenue forecasting solution deployed to OLSPS. Now, the business unit hasn't updated the model in a while, and they want to update data using more recent data, obviously to get more accurate forecasts. To begin with, the end user logs in over here. They go to the Run Model tab that you see on the screen. So in this case, they choose to hold 10% of the data out of the model that they want to update. So they would do this, would take this 10% to test the model on data that the model has not seen. So the end users would have made a custom request that they are able to just this percentage. And it was easy to expose this option to them via the OLSPS front end during deployment. So lastly, they choose a start and an end date for the data set. So let's say this is running part of the span of the past 3 years, because they figure that anything further back than 3 years isn't really suitable for forecasting purposes. Now, because they work at a central claims authority, they know that they have several millions of rows of claims data, right? And that running this claims revenue model will put a strain on an already strained database. So they only need to forecast this periodically. So they decide to schedule to run every second week on a Tuesday and Thursday at midnight, when the database is not really being used much and for other sort of important daily operations. So the updated model now runs on a set schedule, and the revenue forecasts are now more accurate as they're using more recent data available. Okay, so then they decide to switch over to a claims segmentation model via the solution via the drop-down menu that they have. So the purpose of this model is to estimate the likelihood of fraud for each incoming insurance claim. Now, they want to see how their recent claim segmentation model update went. So this model was run on the latest data to pick up more recent fraud trends and therefore improve the ratio of fraud detected by the model. So they click on the comprehensive run log to verify there were no errors, and then they look at the run dashboard that you see on the screen over here. So this dashboard is solution specific, and it shows them only the important metrics and graphs they need to see for evaluating this particular model. Obviously, there is detailed documentation in the help section explaining the metrics and graphs in the context of the solution, and the users would also have learned about the dashboard metrics in a handover training conducted by our team as part of implementation. So in this case, compared to the previous model, the dashboard shows a definite improvement. So they're now happy with the model improvement. They then want to deploy the new model to the automated real-time service. Okay, this service will use a model to assign a fraud risk score to claims going through the main claims system in real time. So in order to do this, they simply go to the promotions tab over here. You see on the screen, and they select their new model and they hit commit. All the dependencies and complexities are handled automatically, which means they are able to avoid many hours of coordinated, often after hours integration updates involving usually overbooked IT resources. Having deployed the new model, essentially at the click of a button, they then want to run 1,000 past claims through the new fraud model to test that they could get, to test that they get the expected responses here, right, and fraud ratios before going live. Okay, going live would mean that all the new claims recorded on the main claim system would be automatically processed by the model and assigned a fraud risk score. So they don't want to do that until they've run some tests on this. So to do this, they go to the API testing tab, you can see over here, and they create a new test run. So as a business analyst, they don't need to know anything about the real-time code formats, and they don't really know anything about the real-time side of things and how it works technically. Thankfully, though, they can upload the claims in Excel format, and OLSPS does all the formatting and conversions for them, converts each claim in turn to a real-time format, and tests it through the newly deployed fraud models. It collects the responses in multiple formats, which can be converted back to a simple Excel and downloaded. So now in this case, as it is only 1,000 claims, they don't bother to schedule the run, and the claims are all scored within a few seconds. Finally, having downloaded and scrutinized 1,000 responses, they are happy for the new model to go live and replace the current live fraud model. So how do they do this? They get the management to sign off, and they let IT know the unique value identifying their model, and IT simply changes the value on their side. Right? The switch is instantaneous. It doesn't require several high-profile IT people to do a lengthy switchover overnight, as would normally be the case. After switching the new model live, IT also logs into OLSPS, but they have an elevated access to the tab that you see on the screen called Systems and Logs over here. From here, they can monitor the real-time claims traffic through the model, and all errors throughout the system appear in a central feed. So they can easily monitor that nothing is wrong after going live with a new fraud model. Normally, this would require IT, data scientists, and probably expensive consulting specialists monitoring several different logs on multiple servers. Thankfully, the live claims volumes of the new model are as expected, and no errors have appeared in the feed. In essence, in the space of a 9 to 5 workday, the fraud model was updated, verified, tested, deployed, and productionized, all by the in-house team. Right, a process that could typically take weeks and more often than not involve expensive external consultants. that was a very brief run through to give you an idea of how OLSPS works in practice. I realize that the last 6 or 7 slides might have flown over some heads, but to summarize, the OLSPS platform empowers business end users by enabling them to do the following. They can adjust key factors and retrain analytical models. They can run regression and post-deployment testing, and they can deploy analytical models on a schedule or into an automated business process with no downtime. I will reiterate here that most other analytical deployment platforms do not offer this kind of functionality for non-technical end users. Enabling this functionality is a big step towards securing business buy-in. And as I mentioned earlier, getting business buy-in is probably the most significant factor in ensuring your data science project is a success. And lastly, OLSPS can be deployed either on the cloud, on-premise, or in a hybrid model. The architecture is elastic and scalable from a simple config file, and there are 2 instances for development and production. Complex analytics simply delivered. That's the phrase I want to leave you with. I'm keeping with the horse theme here, as I did on the first slide, and I'm going to end off by saying that once you've been able to harness the power of analytics in your business, there will be many new and exciting frontiers to explore in this space, and perhaps also could be a tool that helps you get there. Thank you very much for your time. I will be in the speakers lounge after this, and much more importantly, so will my esteemed colleague Tyler Donaldson. He is our head data scientist and product owner. And if you have any questions, especially if they have a technical nature, probably best if they're aimed at him. But I will also be available if you wish to talk about the product or the other work that we do. Thanks again, and I hope you enjoy the rest of the expo.